So the penultimate presentation today, or contribution today, is from Digger Jackson. Digger works for Natural Resources Ltd, an ornithologist. You don't work for Natural Resources.
Natural Research.
Oh, Research Ltd. Close, really close.
Really close.
Anyway, my main impression of Digger is enthusiasm and information I never knew about, like the number of white-billed divers there are off the west coast of Lewis. Anyway, today we're going to be speaking about seabird surveys under difficult conditions in high energy sites and how we can actually manage to get reliable data, I hope.
Something like that. Okay, hi everyone. This is the last talk of today, or is it? Maybe. So, Natural Research Projects, we've been doing a lot of the basic characterisation surveys for quite a few projects. I should say that the work I'm going to present today, although it's me that's sort of done the analysis, but my colleague Simon Pinder, it wouldn't have been possible without him. He is the person who's been organising all these boat surveys and made them happen, and it's about those I'm going to talk about. So unfortunately, he's not able to be here today. Oh, good, I can see this here. So you don't need to read any of these slides. It's mainly until we get some pictures. The reason I said is to remind me what I've got to say. What I'm going to talk about is entirely about boat-based surveys. I did originally think I might talk about vantage point surveys from the shore as well, particularly as we've done a project out here in the Outer Hebrides for the Lewis Wave Array. But there wasn't really anything terribly exciting to say about those. They all went very straightforwardly. And I actually thought the stuff on the boat surveys was more interesting. So that is why I'm not going to talk about the Lewis Wave Array stuff. So sorry, Mark Murray, if you're expecting to hear a bit about that. And what we're talking about here is boat-based surveys aimed at characterising sites that the ornithological interest, the seabird interest, so that we can make good decisions about for EIA, Environmental Impact Assessment, and the Habitat Regulations Assessment, where projects may affect special protection areas. To do this, we use something called the European Survey Seabirds at Sea method, ESAS for short, and this basically involves using a survey vessel, and there's some guideline requirements of what that vessel should be, which is it should give the surveyors on board 5 metres above sea level eye height, so you're perched up above the sea surface. And it needs to be a vessel with good stability, which basically translates to a vessel with 20 metres length or greater. So that's a reasonably sized survey vessel. The other really important thing is that it is carried out in reasonably calm conditions, and the guidance there is not above sea state 4. So sea state 0 to 4 are great, ideally 0 to 3. I'm not really talking about sea mammals. Nevertheless, it is fair to say that in pretty much all these surveys, we are also, a separate team of surveyors is also doing visual surveys of marine mammals, particularly cetaceans, on board the same vessel. And in fact, the guidance for visual surveys for marine mammals, particularly small ones like porpoise and dolphins, is sea state 0 to 3. So that makes life even more difficult, if you like. There is some guidance, some draft guidance that I helped write for Scottish Natural Heritage, as is this document here, which was published 2 or 3 years ago now. So that was myself and Phil Whitfield, but also with help from people like Ian and George Lees, putting together what we all felt at the time was the right way to go about collecting, characterising sites, wave sites and tidal sites. And then for offshore wind farms, there's the Cowrie guidance. And at the end of the day, the two sets of guidance are quite similar with respect to boat-based surveys. And maybe some people say, the basic guidance is that each site should receive surveys at approximately monthly intervals over a 2-year period. That's the norm. It is only guidance. There is variation between sites, but basically that is what we're have been trying to achieve for these sites. And what I'm going to talk to you now about is the 8 sites that Natural Research Projects has been working on, or has worked on, between 2009 and 2014. And of these, there are 3 offshore wind sites, 4 offshore tide sites, and 1 offshore wave site. And in all cases, these are too far off the coast to survey them from the shore. And in each case, the size of the sites requires approximately 1 or 2 days, depending on how big it is, effort out in the boat to complete a single survey. And what I'm going to try and do now is examine the likelihood of achieving this based on sort of real life experience, if you like. So how likely is it that we can complete a survey each month? How likely, should we miss a survey, the protocol is, or the sort of guidance is, try and do a catch-up survey the month after. So the month after we'd receive 2 surveys, but at least a week apart. So how likely is it that should we miss a month, we can make good that shortfall? And then how likely is it that multi-month data gaps develop should we not be able to do this? And then, if we've got time, discuss some of the reasons as to why we end up not being able to survey sites and the implications. So these are the only photographs, so make the most of them. This is what ESAS surveys is all about. You have a boat, a survey vessel, and you normally use a team of 2 or 3 people, and then, so there's a surveyor doing observations, and these are seabirds, in this case, guillemots. It's all very straightforward and routine, and it's a method that's been going since, I don't know, maybe the late 70s, certainly the early 1980s, and it's a standard method for surveying seabirds out at sea. And that's one of its great advantages, is it is standard, and the nature of the data collected is suitable for distance sampling analysis. So you sail up and down a series of transect lines and put the observations into distance categories. So there's routine analysis methods that go with it. And the sites I'm talking about are all these spots on the map. And as you'll see, we've got 1 outlier down here in the English Channel, off the Isle of Wight, 3 off the east coast of Scotland, 3 up in Orkney, and 1 off Islay. And for the sake of making things simple, the 4 up in the northwest corner, the Islay and the Orkney sites, we're going to call those the very exposed sites, and the other ones on the east coast in the English Channel, we're going to call those the moderately exposed sites. It doesn't really matter whether the tide or wade or wind, it's the same method. And they're all roughly the same size sites. And the first thing to do before we go surveying is to be confident that the conditions when we get out there are going to be any good. And we heavily rely on sea conditions forecast, sort of weather forecast websites that predict the sea conditions. And these are readily available. And there's various ones. This is from XC Weather. This is a copied, photo grab off the web. So I hope they don't mind me using it, but it's a great website, XC Weather. Remember it. The point is that in order to undertake a boat survey, we need to decide to mobilise for the survey team to go to the site, and sometimes to get the survey boat to the site or the embarkation port near the site. And that all takes time. And it takes us typically, in order to get there, the minimum amount of time that we need is about 18 to 36 hours, depending on the site. The weather forecasts are really good up to about 24 hours ahead, but 48 hours ahead, they can be a bit iffy. Things are changing all the time. In other words, we make our decision to go to sea with imperfect but fairly good information, but it's all done on weather forecasts. So now we're looking, this is some real data, comparing the moderately exposed site on the left-hand side and the very exposed sites here. And what you can, and this is month by month, January, February, March. Well, that's all, and if it's green, this is the percentage of occasions when we plan to go out that we successfully achieve going out. And you can see immediately that the moderately exposed sites, there's a lot more green than on the very exposed sites. That's a bit difficult to comprehend, so we'll just simplify it. And what we see is that in the moderately exposed sites, in the summer months, March to August, almost guaranteed we'll get out, 93%. In the winter, autumn and winter, still pretty good. The very exposed sites in the summertime are pretty good, we miss a few. In the winter, it's awful. Less than half the times do we successfully get out and complete what we hope to do. So that's pretty bad news. So basically the likelihood of being able to undertake a survey in any one month is strongly dependent on the exposure and the time of year. It's not a great, not very surprising perhaps. The next thing is to consider what the likelihood of making good the following month one of those missed surveys. On the moderately exposed sites, we didn't miss many, but those that we did miss, we could always get them done in the summer months, but rarely in the winter months did a second opportunity come up the following month. Compared to the very exposed sites, even in the summer months, rarely do you get a chance the following month to get out and make good the shortfall. So again, the likelihood of making good your a survey shortfall is heavily dependent on the time of year and exposure. The consequences of all that is that at the very exposed sites, there's a likelihood that a serious data gap can develop, and this is looking at comparing the likelihood of data gaps of 1 month's duration, 2 months' duration, and 3 months' duration developing at the very exposed sites in the bottom and the moderate exposed sites at the top. And basically, no problems on these moderately exposed sites. Yeah, we get the odd 1 month data gap in the autumn and winter, but on the very exposed sites, there's a very high chance of getting gaps of 2 or even 3 months at some stage or other at that site. Basically, it's almost inevitable over a 2-year period that these very exposed sites are going to end up with data gaps of 2 or 3 months duration, and that's bad news. I'll skip that one. It basically says moderately exposed versus very exposed. When we did get out, the sea conditions we experienced were almost identical in all cases, so there's no problem. Once we got out there, it was great. It was all about getting out there. What is the reason for this? Well, the reason is very simple. Is a lack of opportunities of good survey conditions due to bad weather, basically. And in particular, the very exposed sites, as someone mentioned previously, have a 3,000-mile or kilometre fetch to America. And so you get these huge swells developing, which can take many days to settle down. A more minor issue is that we missed opportunities, and that is often due to poor forecasts. Occasionally we had low boat availability. Some of these things are compounded by other things. So, for example, in the winter time, you've got much less daylight, and so you've only got those. Well, in the summertime, you might have, the sea conditions might calm down in the evening or something, and you can still get out. Another problem with which definitely adds to the difficulty of the very exposed sites, because they're all off the islands and off the west coast, is that the mobilisation time is quite a lot longer there. So we're having to make our decision to mobilise on a poorer quality forecast. So this is the last slide. Basically, as I have shown, you're setting yourself up for a fall if we think it's really important to get out to these very exposed sites every month of the year. So the question really is to start asking the question, how many survey replicates do we actually need? And no one's actually done any analysis on that. This once a month for 2 years was a sort of best guess. And finally, to say that one of the ways you could get around it, but as a cost implication, is that if you use a substantially bigger boat, and we're talking about sort of Calmac ferry-sized boats, 40 plus metres, then you can work in a much heavier swell. The problem is, to the developer, big boats are hugely more expensive than a 20-metre boat. Thank you very much. That's the end. Any questions?
Thank you very much, Digger.
No problem. Any questions?
Right. The final contribution.